All right, welcome guys. Today we're going to be implementing a stack, we're going to be implementing a queue using a different data structure, and we're going to be learning about templates in the use of creating a class. A template allows you to have a class hold different kinds of data at different times. So instead of having to make a linked list of integers and a linked list of doubles and a linked list of chars and a linked list of floats and a linked list of shorts and a linked list of longs, and having to copy and paste your linked list class over and over and over again, what we can do is have C++ do the copying and pasting for us. So let's come over here, and we're going to start up a brand new thing. We're going to include list maybe, and vector maybe, and deck maybe. We have some options here. Okay, so what we're going to do is we're going to make a stack class, and we'll make a queue class, and queue class. Sometimes people will misspell. Sometimes they'll misspell it like okay, okay. Sometimes they'll just spell it as a queue. If you remember from last time, a stack, you push, you push, you push, you push, you push, you pop, you pop, you pop, you pop, you pop. So it's like a stack of plates. A queue, people come into the end of the line and they come off the front of the line. That's the difference between a stack and a queue. And we usually implement a stack and a queue using another data structure already. So it's actually a very simple implementation. So the first thing we'll need to decide is what data structure we should use for this. And we'll actually put that off a little bit. What I'd like for is from the people that are active and not AFK right now, go ahead and see if you can remember the names of the 4 functions you need for a stack or for a queue. They're basically the same. No, don't answer more than one word. So let's see if we can get from everybody out on Discord here what the names of our 4 functions should be. So we need top. Okay. We need pop. And the return value I'm going to leave blank here. We need pop. We need push. And that's going to need something inside of here. And top, pop, push, and size. Very good. So size, what type should we return from size? Size t. Okay. Should also be a const. Okay. So the question is, are we going to make a stack of integers, or are we going to make a stack of floats, of doubles? What do you guys think? Or you can say anything to prod you a little bit. How about our stack class would work with any type? Wouldn't that be cool? Yeah, go ahead and say that on chat. Chars? Yeah, sure, that's a possibility. Anything? Anything, exactly. So the way that we do that is we say template class T. Alternatively, this is exactly the same thing here. This is exactly the same thing here. They're just 2 different ways of saying the same thing. What we can do here is we can then do this. Voila. So when you see the T here, that is like a blank. It's like a fill in the blanks. It's like a Mad Lib where like the word will appear later. And so do you guys remember when we make a vector, we say like a vector of ints, right? And vec, or we can have like a vector of chars named vec2, something like that. You guys remember putting these things in angle brackets? And I've never really explained what's happening there. Well, now you're going to learn. Okay. So we can make a stack of ints now. So a stack of ints, when you make the stack class, you put a little angle bracket and an int in the middle there. And then what happens is that int fills in for t. So everywhere you see a t here, it turns into int top. And it turns into push const int. You guys understand? Not constant, but const int, right? So everywhere you see a t, anywhere within this class, and this thing here applies to the entire class, okay? So if you put template class t, or template type name t, same thing, in front of a class, everything within those curly boys, anytime you use the word t, it will fill in whatever word, whatever type the user puts in here. And so if we do this again with stack of strings, name s2, so we don't have to copy and paste the same data structure every time. We can just make one stack class, and that stack class can work with ints or floats or doubles or strings, and we don't have to keep copying and pasting the code. C++ does that for us. C++ will literally generate the code every time we do something new with some new parameter in those angle brackets there. It will copy and paste the entire thing here. Essentially, this is what C++ does. If you're ready for this, it's just going to come in here and paste it, and then it does this. Okay, you guys understand? So it just comes in there and replaces every instance of t with int, and it generates a new class for you. Okay, so that's nice because I don't want to have to copy and paste myself over and over again every time I want a new class of doubles or a class of floats. I just want to make a class for stacks once. Okay. So now let's come to this question. What data structures should we use? So which data structures do we know have the ability to push and pop at the end in order one time? We're looking for order one, top, pop, push, and size. Okay. And so which data structures do we know? It's got to be able to grow. You need to be able to just keep pushing things onto the stack as much as you want till you run out of RAM. So arrays, probably not one of our possible answers because arrays are fixed in size. Vector, yeah, vector is definitely one of them. So we can definitely have a vector that's named vec here. Oh, not int, not int, not int, not int. T. So whatever type T is, it's going to be a vector of that thing. Q, nope, not a Q. Q won't work because stack has to push and pop off. You have to have push back and pop back in order one time. Stacks, sorry, run stack. No, Q, yeah. So you can't use a Q to implement a stack because you push off the back and you pop off the front. So you can't use a Q to implement a stack. A linked list, yeah, a linked list would work, absolutely. So you could have a list named L. What else? What other data structure would work to implement this? You have to have order one, push and pop. It's one we haven't really talked about. It is a combination of vectors and lists. It is called a deck. Okay. So all three of these options are going to give you order one, top, pop, push, and size. All of them. So it's kind of our choice, which one we want to use. So once you get a tie on the big O notation, then what you need to do is benchmark it, which is one of the reasons why this semester we've been spending so much time benchmarking. It's like you don't have to do a whole paper or anything. Like whenever I've got an option like this, I'm like, I don't really know which one to use. I might have an intuition that vector is going to be faster or something, but I'll just write a little code. Let's do a million pushes and pops and different combinations, and start a stopwatch, end it, and then I switch out vector for list, run it again. Switch out list for deck, run it again, and be like, oh, vector's fastest. All right, cool. And there we go. All right. So let's pretend we've just done that benchmarking. I don't want to belabor the point. But let's just say we've benchmarked it and vectors are the fastest, which they probably would be. Linked lists are not super fast. They're kind of slow. Okay, so how do we get the last element of a vector? You guys remember? How do I get the last element? It's on the list here. How do I get the last element? Top. Remember when we think of a stack, we think of a stack vertically. All the other data structures are horizontal for some reason, but stacks go up and down. Queues go left to right, like front to back. Vectors go front. I don't know. It's just mentally they're oriented vertically. Okay. So the top function on a stack is going to get the last element of a vector. Back, not end. If you get end, you try a returning end, that's going to be returning an iterator to not the last element, one past the last element, right? You got to be very, very careful about that. Now, if you want to be super job security This would work. So if you dereference a pointer to the last element in the vector, that would certainly work. I would not write code this way, though, unless you're trying to make your code so complicated they can't fire you, in which case it's fine. Add some extra levels of indirection in there. Let's add a reference and another star. It's great. It's good coding. It's just, you just keep doing this as many times as you want. Just have fun with it. No. We'll just do this. Okay. So vector.back returns the element in the last element of the vector. Easy. One line of code. We can one line this whole thing. In fact. Okay. Pop. How do we delete the last element in a vector? How do we pop the back element of a vector? Do you guys remember? Vector dot. How do we pop the last element off of the vector? Pop. Very good. Done. Okay, we can one line this. Why not? Okay. Push. How do we push to the back of a vector? Please, everybody, you should know this. Everybody should know, how do you push to the back of a vector? Pushback is correct. Good. Week 5, C++. Yeah, roughly. Okay. So vector dot pushback. And we're going to push the new guy to the back of the vector. And then we got one last thing. How do we get the size of our vector? It's the name of the function that tells us how many elements are in the vector. Not the capacity, not the maximum size, but the actual number of elements that are in our vector right now. Get size. Just size. Yep. And we'll just one line these guys. Why not? Just keep it compact. All right. Yep, done. Okay. Let's see if this works. So we can say s dot push 10. So push 10, 20, 30, 40. And we'll say while s dot size. In other words, while s dot size is not 0, right? Cout s dot top and s dot pop. And there we go, 40, 30, 20, 10, right? Because it's a stack. Last in, first out. First in, last out. Yeah. You push a 10, you push a 20 on top of it, you push a 30 on top of it, you push a 40 on top of it. When you pop, you get the 40, then the 30, then the 20, then the 10. Okay. That's your quiz for today. Any questions about this? Pretty easy, right? Like, if you guys had to write a stat class for like a job interview, you should be like, thank you. Right? Like this is about as easy as it gets, right? Like as far as like writing a brand new, data structure. It kind of represents the concept of an ADT, which is the notion you have an interface, right? You have the push, the pop, the top, the size. That's about it. That's all that you really care about. And then under the hood, it doesn't actually matter how you implement it, right? When you have an ADT, all that matters is really the interface and that they behave correctly. You don't have to know, are they using a vector? Are they using a linked list? Are they using a deck? They don't care. As long as they keep their performance guarantees with order 1, top, pop, push, and size, you could usually not really care which way they've implemented it. It's kind of nice. All right, now let's do the same thing for the Q class. Quit. So you can make a Q class using a vector. I don't know. Let's put another to do here. Which class should we use for Q? And then in our public section, I'm just going to copy and paste these 4 lines here, and it's not going to compile. Anyone know why? Thank you, Ben. Thank you. Never change. Okay. So, why is it yelling at me? Okay, let me throw a vector in here, because it's yelling at me for not having a vector. That's not why there's a problem. Why is it mad? Yeah, and can we use a vector? There is no pop front on a vector. Remember, a vector and a stack are really the same thing, because the stack you push and pop on one end, on a vector you push and pop on one end. They're the same class, essentially. A stack is really just a vector with less functionality. But a queue, you push on one end, it's like you push in the back, you pop off the front. And you can't do that really with a vector, not in order one time at least. It would be an order n. So we don't want to use the vector for it. But why is it mad here? What am I missing? It's mad at me about these t things here. Why is there unknown type named t? Didn't I put template class t up top? Didn't I do this up here? Why is it so upset? Doesn't that apply all throughout the rest of the... No, it doesn't. When you say template like that, it applies to just between the curly braces. Yep. So this here applies between here and here. It doesn't work down here. If I were to try and use, I don't know, t I, be like, what? What is it? Right. So this template type name t thing only applies to the next class or function that you declare. So, which class should we use? Vector is not good. Array is not good, because you can have, ever increasing size to your queue. So array is not good. Vector is not good, because you have to push in the back and pop off the front. So which data structures have we worked with would work here? What do you think? You do a list. And we can do a deck. Because list, you can push and pop off the front. You can push and pop off the back. Same thing for decks. So which one do you guys want to use? Doesn't matter to me. We're going to be pushing and popping like 4 things. You're not going to notice any speed difference in it. Okay. List, just because we did that, cool. I am on board with using the things that you learned, even though I would choose deck. Decks are faster. Yeah, like, lists. We learned lists, so we learned lists. We should use them. We should pretend that they're useful. Okay, so okay, we're done. Nope, almost done. Instead of pop back, we need pop front. That line there is the only difference, right? Instead of popping off the back, we pop off the front. That's it. That's the only difference between a stack and a queue. Yep. Everything else is the same. Okay. So that is a fully functional stack class here. There's a fully functional queue class. It's templated, so you can make a queue of strings if you wanted. Queue of strings. Queue. You can do that. It's fine. I don't know, maybe this will be like a list of people at the bank or something. Yeah, so we could say q.push, Bill. And Josh, Andrew, and Luke. So Bill enters the line of the bank first, Josh enters the line of the bank second, Andrew third, Luke fourth, and then we're going to pop them off in order. What? That also needs to change. Thank you very much. All right. There we go. All right. So instead of the top being, yeah, with a queue, we don't talk about the top of the queue. We talk about the front of the queue. So the front of the queue, there. Okay. And the top of the stack. Because queues are left to right and stacks are top to bottom. There we go. So front. instead of the back. And there we go. All right. Yep. So Bill's first, Josh second, Andrew's third, Luke fourth. You guys understand? Easy peasy. That's really it for stacks and queues. There's really, yeah, I don't know. I can't really make it harder than this, guys. I'm sorry. We've already templated them. Yeah, there you go. 4 lines of code, basically. That's it. That's all there is to stacks and queues. So hopefully, you know, when you get your job interview question, they're like, write a stack class from scratch. You're like, all right. Having simple containers can be useful. Yeah, it can be. I mean, you know, if I had to use a stack class, I'd probably just use a vector because it can do more. You know, like you know, the stack class is just a vector with some of the functions turned off. All right. You're like, well, you know, you're not supposed to be able to see the inside of the stack. Yeah, but kind of I do. You know, like if I'm debugging something and I want to see what's on the stack, you know, I kind of want to see it. You know, like I kind of want to be able to iterate over it, you know, and take a look and see if I screwed it up somehow. And with the stack class, you can't see anything except for the top element. And for the queue class, you can't see anything except for the first element. You know, so if you want to do something simple like print the whole queue out, you have to do so by destroying it. You know, and so it's like, I'll just use a list instead of a queue. I'll just use a vector instead of a stack. Like they're not super useful. It depends on your perspective. I mean, like, you know, a vector is kind of a stack. So maybe they are very useful. I don't know. Yeah, that's all I got for you guys.